Thank you very much. So, I'm going to structure this talk with some questions. And first and most importantly, who the hell is this guy? My name is Alistair Lynn. I'm a software engineer and data minion of late at Thread. Thread is a styling company for menswear. So guys come to us, tell us a bit about themselves, style, brands they like, that sort of thing. And we can give them recommendations on fashion. So this is clothing, this is outfits, looks, advice. It's all pitched around helping people feel more self-confident. This is all done through a combination of human stylists and a bunch of machine learning on the back end. I think it's really quite interesting. If anything in this talk makes you think it's really quite interesting as well, we are in fact hiring. Just to clear that out of the way early, so please do come and talk to me afterwards. So what is A/B testing? Well, as with many things with trendy startups, we like to give old things new names. So A/B testing is your father's randomized control trials of yore. It is exactly the same as the medical industry, as psychology has been using for donkey's years. It is the idea of you can establish information about how people behave by splitting people into two groups, a control group and a test group, and comparing quantitatively their behavior across those two. So the way this usually manifests itself in e-commerce will often be the surface level something like this. We want to optimize, usually spelled with a Z, some call to action button to make people click through. If you're charitable, you will say this is to help improve the user experience. If you're uncharitable and or work in marketing, you'll measure this about how much money you can squeeze out of people. I prefer to think of this as about building good user experiences. So if we have a CTA on a website which currently says next, we might want to try a few variations of that, see if we can get people to click through it more. Shop now might be one we want to try, like see if we can explain something to people better. I want in, like group mentality thing, see if that works. Try something a little bit different at the bottom there. And we'll measure quantitatively how this changes people's behavior. So why might we want to do this? Well, basically, it works. Amazon do this at an industrial scale. Google do this at an industrial scale. In fact, virtually any big social network, advertising company, e-commerce place will be doing this at scale. Every centimeter of their user experience will be tested and tested and tested to really understand how people are behaving and to really optimize for the user experience. So A/B testing can make your metrics go up and make your stakeholders very happy. But more interestingly to me, at least, it also helps you understand your users. Now, the way to understand how people are interacting with some experience, the classic way is to talk to them, which is a very good way of understanding things, and it helps inform you as to what the questions to ask are. But there are problems with this. Firstly, what people say and what people do are not necessarily the same thing. People will say they have one experience, but their actual, how they behave is not necessarily aligning with what they've said. And the other thing is, there is a built-in bias here, because if you're reaching out to your users to come and contact you, you're not going to get a representative cross-section of your user base coming back. The people who respond to the phone invitations, the surveys, tend to be, by and large, your early adopters, people who have had a really great experience, or people who've had a really bad experience. Anyone in the middle, probably not going to bother to respond to a survey. So if you're just judging what your current user experience is by the people who are getting back to you, you're not going to be getting a clear picture of what things are like for the typical user. A/B testing doesn't have that property. A/B testing is quantitative rather than qualitative, and is measuring people's behaviors and is working across all of your users. So how do you do it? Tough question. The thing is, there are lots and lots and lots of blog posts and talks about people saying, A-B test is wonderful, you should A-B test all the things, here's the great things it can do for you, and here's the ways you can analyze it. But there's not a lot of time spent on how you actually run it. What are the nuts and bolts? Because it's actually quite tricky. And most of the places that I've seen that say, here's how you should run a test, basically boil down to, here's why you should pay us money to run your tests for you. Such places may work for you, to be clear. For us at Thread, they tend to be a bit too opinionated. Opinionated in how to interpret the results, but also opinionated in how the testing works. See, the classic tests are the surface level stuff. We want to change the copy on a page. We want to change the color of a button, being the absolute classic. It's all a bit shallow. We want to be able to use this stuff to test bigger things. We want to test changing how we frame something across the entire site. We want to be able to test swapping in new machine learning models or strange parameters to our machine learning models. We want to test as much as we can because we found it to be a good way to actually understand what effect things have. And that's not really something that's an option with Google Analytics' A/B testing thing. So we wanted to do it in-house a couple of years ago. And whatever our system is, at the time we thought, we want these sorts of conditions. We want to be able to split people such that n% see one thing, n% see something else. We want to be very sure that, my laser pointer is not working. Oh, there it is. We want to be very sure that if someone comes back, they see the same thing every time. If someone comes to a landing page and sees one thing and then comes back again and sees something completely different, first, you don't know whether to credit the original thing or the later thing if they convert. And secondly, that's just a weird user experience. You want people to see a consistent view of the site. And finally, we do not want to blow the page budget. Site speed matters. Site speed is a big thing. People are very sensitive to how fast a page loads. It is frustrating to have a page take that little bit extra time to turn up. That's bad for the users. It's bad for you if they're not buying from you. It's not a good thing to have slow pages. So we want our A/B testing setup to be fast because people are sensitive down to tens of milliseconds on page speed. Our first pass at this was to just bung everything in the database. Thread is a Django code base. That's kind of the way things are set up. So we'd have a model for any experiment we're doing, a database table for any experiment we're doing, connecting the user who's getting some experience with which experience they're getting, which is all right. That obviously takes linear space in the number of users you have because you need a database row for every user, which isn't great. It needs a database migration before the test, but we can live with that. It gets messy. See, the variant, which is either control or test, if we were running a two-way test, we have this enum thing. It should be just a Boolean, but it's not. It actually looks like this. There's 4 possible options. See, if we're running a test on people who've just signed up, we want to see whether a particular thing, how a particular thing changes people's behavior. In this case, it was a click and collect setup. We can't sensibly measure that if we're testing a tiny test group of new users against a control group containing everybody who has ever signed up. The behavior of people who have been around for a long time will be different to the behavior of new users. Past behaviors are not indicative of present behaviors. It's not a good idea to have one group massive and one group tiny when you're trying to compare their behavior. So we have this legacy thing. So it's kind of the same as control. It will show you the same user experience as if you were in the control branch, but they're excluded from the analytics. And then we hack in this extra thing so that we can put some test users onto the test branch, but have them excluded from the analytics so that we can actually test this thing in production. It gets messy, and it gets messier. See, this is all like how we decide what someone sees when they've gone to a page, but we need to decide which branch they're going into when they sign up. And at the time, this is a small snippet of about a 200-line function which ran on users that signed up, doing decisions for every test we had running on which version of the site people would see, and with a bunch of extra rules, and doing a ton of database writes, a separate database write for every test that we had live. It was a mess, it was ugly, it was slow. We had, this comment is out of date because it's an unmaintainable bunch of rubbish. This was not the way. It worked, to be clear. This worked, but it made us very unhappy. So we wanted a better way. And the better way, something like this. Instead of picking who specifically gets what experience, we will group people arbitrarily based on essentially a hash of their user ID into one of a number of bins. For us, it's 300 bins, buckets. And then when we're deciding to launch an experiment, we will allocate that to those bins, not to the individual people. This removes all of the decisions that we need to make when someone signs up. If their user ID modulo 300 is 150, they will get the experience of bucket 150. We don't need to make any other decisions. We don't need to do any database writes when they sign up. It is fast. 300 buckets is a tiny, or 300 variants of the site. Takes a lot less memory than 3 million variants of the site for 3 million users. We can keep that all in memory, which means we don't need to be doing any database reads when someone hits a page. So this system is much faster because it can be all reading out of memory. And we farm all of the stuff about the testing bit to a separate service, which just worries about running tests. All any of our other infrastructure does is poke that with a user ID and ask, what should these people see? So our web servers, our machine learning stuff doesn't need to care about what tests are running. It doesn't need to care about the difference between the status quo and a control group, even though they're saying the same thing. It doesn't need to care about any of these things. It just says, what should I show this person? And a service comes back and says, show them this. So this still gives us the repeatability that we had with the old system. The same person will always see the same thing if they have the same user ID. We can split fairly across the two users, across two branches of a test, but it's got a bunch of improvements. There's no inserts when someone's... This laser pointer is useless. I'll go the old-fashioned way. There's no inserts when people sign up, which makes sign up fast. It's fast on page loads, it needs much less work to maintain, and it takes constant space in the number of users instead of linear in the number of users. So, a quick demo. I did promise this, as I found out yesterday in my abstract. So, here we go. So we're going to be testing a e-commerce page which looks suspiciously like one of Bootstrap's example designs. And we're going to be testing if we can change one of these buttons to get people to click on it more. So this page is all backed by Jacquard, which is our A/B testing service. Jacquard can tell you what to show in this page. So all this page is doing is basically rendering a template, substituting some values of a dict in. All the experiment side of that I will show you in a minute. So Jacquard, our A/B testing tool, is controlled through the command line. This is our current defaults. This is the basic experience people are getting. This is basically key value pairs. The current header on the page says pricing. These are the values of the CTAs. We can change the defaults. with Jacquard set default. My shell has gone ahead of me there. So if we want to change the page title to prices, we do that. It's one command. The page title changes to prices. Nothing too dramatic there. One nice thing about it is this command line interface we actually make available through Slack. So our product managers and other stakeholders can poke things on the site themselves without needing to go through engineers. Not the core part of what Jacquard does, just a kind of handy side effect. So what we're going to try today is changing this button here to go from get started to sign up. It's not a particularly dramatic test, but these small tests do add up over time. So first, because we are incredibly risk averse, we're going to not launch it to 50% of users and possibly see our metrics tank. We're going to roll it out to a small number of people to start with, just to make sure we don't get any horrible requests on support, or we don't get our error thing screaming at us. We're going to be careful. We're going to show this to, say, 1% of users. So Jacquard can do this. Jacquard can roll out a change of a setting from thing A to thing B to a tiny number of users. It goes Jacquard rollout. 1% get the new CTA of sign up. That's then pushed out. This is a distributed system. We've got lots of web servers. Almost certainly when I reload this page, it's still going to say get started. It was only a 1% chance it wouldn't. But that is now live for 1% of users, and they will be seeing that, and then we can be monitoring all the things we want to monitor to make sure this hasn't made anything explode. Okay, now we might want to actually run an experiment, actually run the test live. 50% of users see one thing, 50% of users see the other thing. For that, we need to load in a definition of our experiment and then launch it. So the definitions of experiments are all in separate files in Jacquard. You can load them manually. We have them in a Git repository so they can go through code review, and then they're launched by CI. So the experiment files look something like this. We have an experiment ID, a descriptive name. We're going to try a new CTA sign up over the current get started. And then the branches of this test are, there's a control branch who are getting the message get started, and there's a test branch who are getting the message sign up. Implicitly, this is a 50-50 test. You can make it a smaller test if you want. This is going to be 50-50. So if we then load it into the system, that will then ship it off to all the other nodes, ready for launching. There is only one node in this cluster, so that's not a particularly exciting thing. And then it can be launched by us or a product manager with Jacquard launch. However, this is actually going to fail because the system makes sure you are very explicit about what you want to do, about who is seeing what. The problem here is that we are saying, I want 50% of users to be moved onto my test branch, and I want 50% of users to be moved onto my control branch. The problem is, a few lines up, we put 1% of users onto our, hedging our bets, roll it out early group. That adds up to 101%. And I'm not a data scientist. I'm not hot in the maths. But last time I checked, 101% is slightly above 100%. That is a problem. So Jacquard will make sure you're not giving conflicting reports about who should be seeing what. So if we now finish that rollout off, we're happy it hasn't made anything explode. We're going to roll that back to the default experience, and now we will be able to launch the test. And if I reload this page, there's a 50-50 chance that I'll see one. Yeah, it worked. Didn't when I ran this through last time. We've now got the different experience here. None of this is particularly exciting, I know. It's changing copy on a button. But these small incremental improvements, when you make them a lot of times, can make a huge difference to your bottom line. And eventually, if we're happy that this is how we want to go, we've measured this, people are converting better on this side, I'll go into the measurement in a bit. We might decide to ship it. A product manager might decide to ship it. We want to conclude this test, and this is the branch that should become the new status quo, the new default. We do that. Reload the page, it stays the same because we happen to be in the test branch. And if we show the defaults, these are our new status quo. It's all fungible from the command line and from whatever you want to hook into the command line. There's a bunch of other features Jacquard can do. It can do things about feature flagging if you want to turn a thing on and off without running a test on it, which we found quite useful in the past. I'm not going to demo all of that today because I didn't have time to prepare any of that. But if you're interested, it's all documented, and I can show you if you come and find me. So that's the demo of the tool. Now, I did skip over there very deliberately. How do we actually measure this? We use a very Bayesian approach to how we understand the data we've got back from a test. So we'll set some prior if we're measuring the rate of people converting through registration, so that is of the people who start a registration, how many will finish it. We reckon that's somewhere between, say, 20 and 30%. It's a pretty broad range. If we don't know any better, we'll stick with that range. So our prior belief, this really is awful. Our prior belief is it's going to be somewhere between 20 and 30%. We'll compute the posteriors, again, the Bayesian method. Given the data we've had from the people who are in the control group, given the data we have from the people in the test group, we'll update that. We might say that this random variable, the probability distribution says they're 95% somewhere between 22 and 23%. And in the test group, we're 95% sure they're somewhere between 25 and 26%. Then we subtract the two random variables from each other, which is essentially you take the convolution of the two probability distributions. And what that gives you is a probability distribution over the improvement you've got from your test against the control group. So unlike the more classical frequentist approach, you actually can give an answer to questions like, what is the probability that my test group is better than my control group, or the test experience is better than the control experience? What's the probability that's worse? What's probability that's better by this amount? What's the expected increase to some number we care about for our unit economics? There's a lot more you can get here than you would have in the classical approach, which basically gives you a decision should you ship this thing or not. We do not set a decision rule. We have no prescribed way of saying this test was successful, you should ship it, against this test was not successful, you shouldn't. That is a decision to be made by judgment of product managers, taking into account how a test has affected probably multiple dimensions in how people have behaved, and that's something we've measured here through the A/B testing system, but also taking into account things like the ongoing maintenance cost of one experience over another, taking into account how well an experience aligns with our vision for the product or our values or our ethics, or taking into account what tests we want to run in the future. There's a lot of factors that go into our decision-making on what experience we want to have. And rather than being led by the tests, by having a decision rule which says you should ship this or you shouldn't, we are led by judgment, and we're only using the tests to understand better qualitatively what impact it has, a different experience has on our users. So our reporting currently looks something like this. So this is real. This was from a test we ran about a year ago. We were measuring whether something would have an effect on people finishing registration. It did. So what this tells us is not just this is good or this is bad. It tells us we're 95% confident that the improvement from this new experience is somewhere between, that's about 0.5% and about 7%. Median improvement is here. We can have a look at the actual numbers across the two branches. So we reckon the control group, who had the old experience, they were converting, we're 95% sure, somewhere between 25.5%, 26.5% of the time. This test group, we're 95% sure, are converting somewhere between 26.5% and 27.5% of the time. We can actually look, if we really want to, at the cumulative distribution function. This is a bit of a weird one to try and think about. But for instance, at this 50% line, that is a 4% improvement, which means we're 50% sure there's at least a 4% improvement here, or they'll be 50% sure the improvement is up to 4%. This point here is where this line intersects the 0 line. That's the percentage chance that the test is better by some margin, or is not worse by some margin equivalently. We're pretty damn sure this test is a good one, because this is virtually at 0. And if you really want to, you can actually look at the PDF of the posteriors. They're not terribly useful to the product managers, but they're quite useful occasionally for us for debugging whether we've screwed up a metric. So risks. Of course, there is no such thing as a free lunch. You can't just say A/B testing and get money. You have to carefully manage the risks that come with this. The big one is bias. Confirmation bias is overwhelming. People will see patterns where there aren't any. Our brains are pattern matching engines. This is not terribly surprising. This is a very well understood result, but people will see information where there isn't any. If we ran a short test, changing the color of a thing from yellow to blue, and our report said there's a 60% chance it's better, it would probably be a good idea to switch the color. That's a good business decision. What it's not is a fact. It's not saying blue things are better than yellow things. It's saying this particular thing may be better in blue than yellow for these users in this place, in this circumstances, maybe. 60% is not very strong. With no data at all, it would be 50% because it would be a toss-up whether it would be one or the other. There is a risk in people taking small results and going, that is a fact right there. This confirms everything I was thinking when I launched this test. This is now a fact. We're now, from now on, we're going to make our things this color instead of this color. You can look at data which is totally consistent with no change at all and go, I'm seeing a hint of an improvement here. Hint is a very dangerous word. Always be on your guard if people are saying there's a hint of something. That almost always means there isn't something, but I really wish there was. Survivorship bias is another one. Say we tested turning something off for a group of users. But a few of our stalwarts, people who've been around for a very long time, customers we know by name, get in touch with us. We find out they're on the test branch, and they're going, I really wish I could have this thing back. Please, can you turn this thing back on for me? And we do, because we care about users. You know, we don't want to cause people discomfort. We want people to have the best experience they can have. We are quite happy and quite capable of moving someone to having a particular experience. We'll take them out the tests, so they're not going to influence the results. All good. Do this enough, and your test branch will only have the people in it who didn't complain. That is going to completely screw up your results. If some of the people in the test branch love it and some of the people in the test branch hate it, and then you get rid of all the people who hate it, it's going to look way more better than it actually is. Be careful about who you're taking out of your tests as well as who you're putting into them. And finally, inertia. Think of the massive outcry that happens every time Facebook makes a slight tweak to their design. People hate change. If you run a test where for a whole bunch of users you've had around for a while, you're giving them a new experience, they will probably hate you because there has been a change, even if, in the long run, that new experience would be better for them. Change itself is an effect. And while this isn't a problem if you're testing on people hitting a landing page or coming to you for the first time, it is a problem for existing users, and you do need to control for that. And finally, ethics. A/B testing really is just randomized control trials. If any of you have done randomized control trials, in a medical setting or in an academic setting, you'll know the hoops you have to jump through to get ethics approval. There's thorny issues of consent. None of that has historically applied when we've been doing A/B testing in e-commerce, which seems strange to me. I think about ethics a lot with our testing, and I really must encourage you all to consider your own ethics and what kinds of tests you're comfortable with running before you launch into running A/B tests. Thank you very much. Please.
I have a question. How do you set up the metrics when you wanted to track for example, the CTA or something? You have to set up for each test individually?
Yes, in principle. We have, unfortunately, the actual measurement stuff is not part of the open source part of Jacquard yet. I'd like to move it there. We have a library of metrics we have internally, which we can pick from for a test. We can also write them for new tests. Essentially, writing a metric is just working out exactly what you want to measure, figuring out roughly what the values you expect in it are, and putting a bit of code to pull it out of the database. Metrics don't have to be fast, so they're...
Okay. And one last thing, when you were talking about the 1% of the variant, when you are afraid that it will fail, I don't know if you are familiar with Stuart Frisbee. He's a head of testing in Booking.com.
I'm not familiar.
Yeah, he said a really fun quote. You kind of reminded me. And he always says, like, don't try new variants on 1% or 5%. If the variant should, like, fail, it will fail slower. So you will see, if you test it like 50-50, you will see the worst, or the blowout,
Sure.
Fastly.
So the kind of things we're looking for here are slightly different. This is, rolling things out for 1% is less to test, like, whether people don't like it and will convert slower. Obviously, the more people you put into the test, the faster you'll find things out. This is more to find out, is there some bug somewhere which, for some group of people, throws a bunch of errors if they see this text. This is much more... It's a little bit contrived to put that out for a CTA. That's much more important if we're, like, switching a machine learning backend or something. That's to hedge against the risks of there's a bug which produces errors rather than people are behaving differently.
Hi. With the priors that you're setting up, to what degree is the interpretation contingent on the priors, and are they made available to the people making the decisions afterwards?
We try and set the priors to be relatively broad, and we revisit them from now and then. We don't generally present them as in the reporting, something we may consider. As we try and run tests long enough that essentially the likelihood swamps the priors. As time goes to infinity, the priors become less and less relevant. And we do try and run all tests for at least a week to account for the seasonality, because people behave differently on different days. And after a week, for most metrics we're measuring, the priors aren't that important. It is something we want to get better at in the future.
Just a quick implementation detail.
Mm-hmm.
Use the hash of the user ID to make your control and whatever groups.
Yeah.
If you run two 1% tests back to back, do the same user IDs get selected, or is it smart enough to use a different hash function each time?
The same user ID will be hashed to the same bucket. It's more that when you launch a thing to 1% of buckets, the buckets that get selected are selected at random. So that will be different each time. So people you won't be unlucky and always end up in the I'm the guinea pig group.
Do you run multiple tests at the same time, and if on the same users? And if so, how do you disentangle the effects of the multiple tests?
We do run multiple tests at the same time. We hope that if we're running them on separate enough site areas for a start, the effects will mostly be more or less independent. Also, if 50% of the users in a control group are on the control group of some other test, and 50% are on the test group of some other test, and 50% of the test group on the control group of some other test, and on the test group of some other test, that more or less controls for the effect of the other test. It's not perfect, and we have had problems of interacting tests before, but by and large, as long as you're not testing exactly the same thing multiple times at once, the effects do tend to cancel out. I don't think we have a fantastic way of reasoning about this right now, but we are running mostly independent enough tests that we're not too worried about that. Good question, though. Thanks.
Hi, this is a question more about A and B testing in general. The way I understand it, A and B testing is quite a greedy approach, so you try to constantly optimize small details, right? Like the color of the button.
Yeah.
So since you've thought about this quite a lot, I guess, are you worried about kind of over-optimizing details and then kind of like ending up in, so to speak, in a local optima rather than kind of finding the global optima?
For sure, yeah. This is something that Tim Harford has talked about on a number of occasions. If you want to go and find his talks. The incremental improvements can get you a long way. They will never get you to the global maximum. We don't just make decisions by A/B testing. We consider A/B testing to be a tool. It's a way of understanding how a change affects people. It's not our overarching philosophy. We don't just follow along A/B tests, improving things one at a time. So there's a lot of decisions which are made based on vision and our vision and our judgment rather than based on A/B tests. And we do take wild leaps into the unknown every now and then to see what happens.
Just on the last ethics point, I was wondering whether you had any examples of what you might consider, or what might be considered a grey area ethically, and what kinds of A/B testing a less scrupulous company than yourselves might be subjecting us to.
It's a little dangerous for me to speculate while wearing with my company's name up somewhere nearby. The tests which worry me the most are tests made thoughtlessly from services that people rely on a lot more. For I'm not going to name names, but for instance, companies that offer ride-sharing services. People depend on those. Like, people depend on them to be able to get home safely. If you are going to change something which makes people fail to get their cab home and get stuck like in the middle of nowhere, that is causing really severe risks to people. If you screw up Facebook, people rely on Facebook for their for how they interact with people. You know, if you make it hard for people to say they're safe in some horrible circumstance or any of these things, these things have real effects on people. They can cause real suffering. They can cause real psychological damage. The tests where people's interests are not in alignment with what you're trying to achieve from the tests are basically the type that concern me. I'm mostly pretty comfortable with the test we run at Thread because if we're making the user experience better, we are helping people dress better. We're helping people feel more self-confident. That's all in line with our mission. It's when we're a positive result for the person doing the testing is a negative result for the people being tested on that I think we get into ethically grey areas.
Just continuing on the example you said before, if people are relying on the service and you say that breaking it may actually cause some real problems, wouldn't actually having A/B testing help prevent those issues from spreading? Because if I enable for 1%, then at least it fails only for 1%.
Maybe. It depends on the nature of the test. If you're trying to do something to discourage some particular group of non-profitable customers from making rides at bad times, that's the reason you're doing the test is not aligned with their interests. If you're doing a test to say, we want to change these things to make the experience better for us, and we want to make sure this isn't damaging people, I am much more comfortable with that. It's not that, like, tests are always bad if it's a service that people rely on. It's about the reasons for running each individual test.
Any other question? No? Okay. Thank you, Alistair.
Thank you.